Good morning everybody. As you see, I'm not there today, and today I want to revise with you some factorisation work. So the first thing we want to look at is what we call the null product rule. And the null product rule basically says that if I have A multiplied by another thing, or another letter, value, and that equals 0, therefore either A must equal 0 or B must equal 0. Now this is really important when we're looking at factorisation of quadratics or anything else like that. So let's looking at some basic factorisation. We're going to be applying this rule, or the null rule, all the time. Now, since we have been operating yesterday looking at quadratics, the temptation is to always make every equation look like a quadratic equation. But if I started off with this, and it would say, and we'll just get rid of that. If I started off with 2x outside of brackets 4x plus 6, and that equals 0, essentially what we have is we have one number multiplying by another number, which once again straight away refers to the null product rule. Therefore, what that really comes down to is that 2x, I didn't write very well, so I'll do that again, 2x must equal 0, or 4x plus 6 must equal 0. If that's the case, in the first one where 2x equals 0, x has to equal 0, or over here we could solve the 4x plus 6 and get 4x equals negative 6, therefore x would equal negative 6 over 4. Now, the temptation would be, normally what people would like to do when they see this question here, is they would like to turn that into a quadratic, and the way they would do that would be expanding it. So when you go do something like that and get not 4 but 8x squared plus 12x equals 0. Now that there looks like a quadratic, but in fact you're actually making it harder, because realistically to solve that you're going to have to find a common factor, and the common factor is again 2x, or which will take us back to what we originally started. Or some people like to say, so it's just messy, so don't go through that process. Don't try to factorise something a quadratic unless the quadratic has 3 terms. Now here I've got what I was just talking about. This looks like a quadratic. Unfortunately in this question here though, there is the third part missing. So in other words, you've got the ax squared plus bx. There is no constant at the end. So how do you factorise these? Well, if you notice, we have 2 terms. And within those 2 terms, there is a common factor. And the common factor in this case is 3. Of course, 3 goes into 3 and 3 goes into 6. But there's also another common factor of x. So when you take 3x out of the first term, 3x squared, you're going to be left with x. And when you take 3x out of 6x, you're left with a 2. And don't forget that all equals 0. Now, a way to check that would be to see if you multiply it out, do you end up with your original statement? 3x times x is 3x squared, and 3x times 2 is 6x. Now, our null factor rule, or null product rule, says that either 3x equals 0 or x plus 2 equals 0, which means x must equal 0 or x must equal negative 2. So, when you have questions that only have 2 terms in them, when I'm talking about 2 terms, I'm talking about that's one term and that's another term, realistically, you look for a common factor between those two terms. Now, what happens when we have quadratic factorisation? Now, you've got to remember, this is not new to us. This is just a review part. So, quadratic factorisation, relies on your ability to remember a few things. And what's that to remember? Well, the standard form of a quadratic is ax squared plus bx plus c, and if we let this equal 0, that means you can then solve it. Okay, so the general rule for factorisation is you must find two numbers that multiply to give a times c, and those two numbers must add up to give you b. So, let's have a look at a specific question. So if we had something like x squared plus 7x, well, let's make this look a bit neater, shall we? Plus 7x plus 12, and that equals 0. What we're looking for is two numbers that multiply to give you 12, because of the simple fact that you have really a 1 there. So 1 and times 12 gives you 12, and must add up to give you 7. Well, what do we really have? 3 times 4, 2 times 6, 1 times 12. They are the only three combinations of numbers that multiply to give you 12, and I think it's going to be pretty obvious to you and me. They are the two numbers, 3 and 4, will add up to give you 7. So if this is the case here, we get our x squared plus, we split our middle term up into 3x plus 4x, because that'll give us the 7x, right? And plus the 12 equals 0. Now, generally what I do now is I underline the first two and the last two terms. So what's common in the first two? What's common is the x. So what's remaining? X plus 3 plus, and what's common in the last two terms is 4, and what's remaining? X plus 3, and we say yippee because of our two brackets are the same. Therefore we have an x plus 3, and the remaining bracket is x plus 4. That equals 0. Therefore x plus 3 equals 0, or x plus 4 equals 0, and which means x in this case here would equal -3, or x would equal -4. So, now, but there is one little stipulation here, and it's a simple case here. You will notice that in this case here, the -3 and the -4, or more important, I'll go, sorry, not those two places, that 3 and that 4 actually came from those two numbers there. And that was simply because the number in front of the x squared was a 1. So when you get the coefficient in front of the x squared is a 1, you can go from this line straight down to that line in one step. Okay, from there to there in one step. You don't have to do that stuff in the middle. The stuff in the middle is only required when your coefficient in front of x squared is not a 1. What am I talking about? Well, let's try one. Let's try this one. So the question I'm going to do is this. Now, if a pen works, it will be good. It doesn't work at the moment. So we'll just pause for a second. Okay, here's a question. 2x squared minus 14x plus 8. Now, two numbers that multiply to give you 16, but add up to give you -14. Right, so what have we got here? Multiply to give 16. Well, this is not going to work, I don't think. 4 by 4, 1 by 16, 2 by 8. That's it. Now, therefore, that question here, since none of these will add up to give you that, this cannot be solved. Bit of a bummer. But that's the way the cookie crumbles. Let's try this one. What multiplies 2x squared plus 8x plus 8 equals 0? What multiplies to give 16? And I got 16 from the simple fact of that multiplied by that. Okay, and then these two numbers that you find must add up to give me the value of 8. Well, we've got 1 times 16, 2 times 8, and 4 times 4. And you already guessed it, it's those two we're going to use. So, going through the whole process again, 2x squared plus 4x plus 4x equals to 4x plus 4x makes 8x, plus the original 8 we had equals 0. Go through now and underline that. What's common in the first two is 2x, and you're left with x plus 2. What's common in the second one is just a 4, and you're left with x plus 2. And you'll like this because our two brackets are the same. So that bracket comes out the front. What's remaining is in the other bracket. And don't forget this will equal 0. They're using our null product rule. We say therefore x plus 2 equals 0, or 2x plus 4 equals 0. And to save a bit of time, to solve these, it's going to be the first one, x equals -2, or in this case over here, x equals -2. So this question only has one solution. That one solution is x equals -2. Now, that's the long way. But if I was a smart person to start with, I would have noticed that in my original question, which is the same one I've just written there, I would have noticed something very unique. Every term is an even number, but more importantly, every term can be divided by the coefficient out the front of the x squared, which in this case here is 2. So if I divide everything by 2 on both sides, I end up with x squared plus 4x plus 4 equals 0. Now the beauty of this is, I'm back to one of those nice ones where the value and the coefficient is 1, which means I can chop out a lot of the extra work. So what two numbers multiply to give me 4, but add up to give me 4? Very straightforward. 2 times 2 will equal 4. So therefore, and 2 plus 2 equals 4. So my brackets are x plus 2. And the other bracket will also be x plus 2. So you notice I've already saved myself a lot of work. So, what am I trying to say here? When you're doing these questions like this, check that the coefficient out the front, if it's divided, can be divided into all of the other two coefficients, the value of the b value and the c value. If you can, you will get down to a very nice looking quadratic. Final question. You're asked to solve this. Well, the left hand side here looks like a quadratic. The right hand side looks like a fraction. Now we don't traditionally like fractions. So what we're going to do is we're going to remove this fraction. And the simple part is you're going to remove this part first. And the way we quite simply do that is that we multiply both sides. Oops, what happened there? Multiply both sides by 4. And you multiply this side by 4. Now, when we do that, what we end up with is 4x squared minus 8x plus 8. And on the right hand side, we quite simply end up with just that, because these 4's cancel out. So now, if we get this part here and bring it all to the left hand side, we will only have 1x squared left, because 4x take 3x squared gives 1x, minus our 8x plus our 7, because I take 1 off both sides, and what's left over is on the right hand side. And you know straight away I've got a nice value, I've got a nice coefficient value in front of x squared of 1, which is what we really like, because it means we can do our shortcut method. So what two numbers multiply to give 7 but add up to give me negative 8? Well, we've got 1 times 7. That just gives me a value of 8. But don't forget that two negatives multiplied together end up with a positive. And if you look at those two numbers, negative 1 and negative 7, they add up to give you 8. Negative 8, sorry. So straight away, I can write my two values down. X take 1 and x take 7. And that equals 0. Therefore, each of those brackets could equal 0. So therefore, the first bracket, x would have to equal 1 to make it equal 0. Or the second case, x would equal 7. So the goal with these types of questions here is quite simply, you have to make them look like a quadratic. What do I mean by that? You have to make them look by that line before you can go ahead and do any factorisation in which to solve it. So you're rearranging the equation, number 1. You're making it look like a quadratic, number 2. You are factorising it, number 3. And then 4, you are solving it at the very end. Now you should have enough of these questions to go through and try exercise 7.2. Don't do the very last question, but you should now be able to cope with the rest of those questions. Thanks a lot, guys.